All right, question number 21. These are review questions. And so how do you know if this series converges or diverges? What is this? Is a geometric series. So the common ratio is 3/4. Because it's less than 1, it converges. We call that the geometric series test. And how we find the sum of it is a formula. We need the first term. So if I plug in 1, that's 3/4. And then 1 subtract the common ratio, which is also 3/4. If I get common denominators, if I write this as 4/4, that's 1/4. The 4's divide out, and the answer is 3. 22. It's always best to do it first, right? Get support if you need it. Again, it's geometric. We have a base to an exponent that's a variable. The common ratio is 1.3, so therefore it diverges. I can't spell the word by. Because the common ratio is greater than 1. 23. Again, we have a series. This is not geometric, so we're not using the geometric series test. We're not looking for a common ratio. Instead, the power terms. So we have to write this first as a limit. Please do that. I know it's easy not to. And understand n squared over n. It's more powerful on top, so it's going to infinity. So this diverges by the nth term test. 24. The derivative of a function dy by dt is negative 3t squared plus 1. If the graph of the function contains the point 310, find the equation of the function. So we're going to solve this diffie-q. So step 1 is to separate the variables. I'm going to write this as to the negative 2 and multiply dt to both sides. This is just y. We're going to add 1 to the exponent and divide. That makes it positive 3. And then 1 is just t and then c. If it contains that point, then y is 10 and t is 3. And then we'll solve for c. 3 to the negative 1 is 1/3. So I want you to see that these cross out and leave you with 1. So what we have is 1 plus 3. That's 4. Take away, you can see that c equals 6. So the equation then, come back here, and you have your equation. 25. As I've said, these are probably the most important questions when you review, because what you don't practice, you forget. So I'm going to write this calculus friendly. And it says find an equation for the family whose function, whose derivative is that. So I'm going to integrate this. So I'll separate the variables and integrate it. So dy is just y. Here I'm going to add 1. Instead of dividing, I'm going to do the reciprocal. Notice the 3's divide out. So I have 2x to the 3/2 plus c. Again. Then it says find a particular, that's a, find a particular function that goes through the point 4, 0. So in that case, y is 0, x is 4, and then solve it. So the denominator means square root. So the square root of 4 is 2, and 2 cubed is 8. So that's 16. So when you subtract, that's what the constant's equal to. So y equals 2x to the 3/2, subtract 16. Number 26. I want to integrate from 1 to 4, 2 root x minus 1 over root x. The first thing I noticed is that we have a monomial in the denominator. So I'm going to write it separately as two fractions. So If I just look at this, the root x's divide out, that's 2. If I just look at this, it's subtracting, and then I write it calculus friendly. 1 over the square root of x can be written as x to the negative a half. Now it's easier to integrate. So that's 2x. Add 1 to the exponent instead of dividing the reciprocal, and that's 1 to 4. And then plug in 4. Subtract, plug in 1. And if you did have to simplify this, that's 8. The square root of 4 is 2 times 2, that's 4. This is 2. 1 to any exponent is 1. Take away 2, that's 0. So I think I'm left with 4. Double check my answer. Good. All right, 27. Again, best is when you write it down. Again, these are so important because what you don't practice, right, you're going to forget. So we're going to integrate from 1 to 2. So what I notice here is a few things. So I'm going to write this as 1/2 3x minus 2 to the negative a half dx. So I'm going to write it friendly. I recognize where the hook comes from. So the derivative of 3x take away 2 is 3. That's the hook I need. It was 1/2 and it became 3. So what's 1/2 divided by 3? And that's 1/6. So it's going to start with 1/6. I'm going to add 1 to the exponent, divide or the reciprocal, and then I'm integrating from 1 to 2. So I have 1/3, plug in 2, subtract, plug in 1, and then if I needed to simplify this, 6 take away 2 is 4, and the square root of 4 is 2. 3 take away 2 is 1, and 1 to any exponent is 1. So that answer at the end should be 1/3. 28. Integrate from 0 to 3. What do I notice to do here? So if I make it calculus friendly, I have x plus 1 to the negative a half. If I look at the hook, they're unlike terms. This is going to be a u substitution. Because the derivative of x plus 1 is 1, and I have a 2x. They're unlike terms. This is the direction I'm going to go. X equals u subtract 1, and the derivative of x is the derivative of u. So I'm going to rewrite this. I'm going to use this to change it to u. So if x is 0, 0 plus 1 is 1. If x is 3, 3 plus 1 is 4. And then I'm going to do a substitution. So x is u subtract 1. X plus 1 is u to the negative a half. And dx is du. All right, now I'm going to do some algebra to simplify this. So I'm going to distribute. So that's 2u, and there's an exponent 1 there. Add it, and that's positive a half. Distribute again. That's negative 2u to the negative a half. So see the algebra there. Now I'm at a step where I can integrate it. So I'm going to add 1 to the exponent and then the reciprocal. I'm going to add 1 to the exponent and the reciprocal, and that's 1 to 4. So I have 4 over 3. And I'm going to plug in 4 first. 4, I'm going to plug 4 first. Subtract, parentheses. I'm going to plug in 1. If I simplify this, the square root of 4 is 2, and 2 cubes 8. 8 times 4 is 32. Anyways, this all simplifies to 16 over 3. I'm going to let it go. 29. Practice taking derivatives and knowing your derivative rules. So the derivative here, the derivative rule for sine is cosine, copy, and then inside is the hook, and that's just pi. The derivative rule here is we multiply by 2. and subtract 1 to the exponent. Number 30. The derivative rule here is going to be the quotient rule. That's the bottom times the derivative of the top, subtract the top, times the derivative of the bottom, and then the bottom squared. Number 31. In this situation, we're going to follow the hooks. So first of all, the derivative of tangent is secant squared, and then I copy. Then inside the parentheses is a logarithm. That's a fraction. What I see goes in the denominator, and the derivative of that goes in the numerator. 32. So write it down, pause, do your best first. The rule for E is to copy it. The hook comes from the exponent, and that is the product rule, the derivative of the exponent. That's the first times the derivative of the second minus or plus the second times the derivative of the first. So let's see, what do I make? This should be a negative sign. So you end up with negative sine squared x plus cosine squared x. 33. Turn the page. Sketch graphs and show shaded areas represented the values of these definite integrals. So from negative 2 to 2, the absolute value of x cubed plus x dx. So x cubed plus x, if I plug in like 0, 1 will give me the answer 2, 2 and so on, it goes up. And then normally these values, if I plug in negative, would go down. There's a reflection here. That's what it's going to look like this. And then from negative 2 to positive 2, this is the area we're talking about. So because these are odd numbers, when you plug in negative, it's going to be the same answer but negative. But because there's an absolute value, those negative values become positive, so it just creates a reflection. And then it says, which one matches that? It's curved, so it can't be triangles. Absolute value is not even necessary for the given limits. Use symmetry. I like that one for 33. I like the idea of using symmetry because you could do half and then double the answer. That was A. 1 and A, right? They match. 1 and C match. Okay, how about 2? So for number 2... Hey, Joseph, can I call you back in 5 minutes?
Yeah, just send it over whenever you can.
Okay, I will.
Thank you.
Bye. So for number 2, we're integrating from negative 2 to 2. X squared plus 5x plus 6. That's a parabola. If I graphed this, I'd look at the intercepts, which are negative 2 and negative 3. So negative 2 and negative 3, and then it's a parabola that goes up. But the part underneath, and we're going from where to where? We're integrating from negative 2 to 2. So negative 2 is here, and it just kind of goes up, right, from there. And this is the area that you do, and this is curved. And the part that would be underneath, the vertex would be here to the left. So it's just from here, the parabola going up to the right, and that shaded area from negative 2 to 2. That would match with B. Absolute value is not even necessary, right, because the part that's below is not even a part of the integration. So it's not even necessary here. So 2 and b match. For 3, if I factor it right away, it's going to be plus 6 and minus 1. So we have like negative 6 and 1. So if we go from negative 2 to 2, there's going to be a part that's underneath here. So between negative 1 or positive 1 and negative 6, in the middle, so this part would actually go underneath here. And so the part that goes underneath is now going to come up. So from negative 2 to positive 2, this is what it would look like in terms of being curved. D says the integral can only be done by using more than one. That's true. So you'd have to do this integral and this integral. You'd have to set up 2 integrals the way it looks. For the last one, it's a line. So negative 2 to positive 2. X plus 1. So at negative 1 is the vertex of the V. And so at negative 2, the answer is 1. And at positive 2, the answer is 3. And this is the one that looks like triangles. So from negative 2 to positive 2, this is the one that looks like triangles. So that one matches with A. And then the last part is set up integrals which could be used to integrate the following ones. So for 33, so for part 1, the integral would be from 0 to 2. And then you would double the answer because of symmetry. For number 2, you just integrate everything. So from negative 2 to positive 2, x squared plus 5x plus 6. The bars don't even affect anything. You just take away the bars and just make them parentheses and just integrate it. For number 3, you'd have to have 2 of them. So one would go negative 2 to 1. And the other one would go 1 to 2. And then the last one, you just have to use triangles. So for this last one here, for part B, you just actually have to use triangles here to integrate it. This is evaluate the last one using triangles. So that would be 1/2 the base times the height, 1/2 the 1, 2, 3, the base times the height, and you have your answer. So it's 1/2 plus 9 over 2, which is 10 over 2, which equals 5, and you're done. Mr. G Math over and out. I'm so proud of you for finishing your work. Keep up the great work. Till next time.